Hello, welcome. Morning. A bit late today. Doing lesson three. It got delivered last a week ago today, actually. So a little behind recording. Meant to do it this weekend. Didn't get around to it. Just honestly needed a weekend where I was a little more disconnected from things, so I just didn't do it. So we're gonna do it today. Let me make sure I have my notes everywhere that I need them. I think I do. Move this. Where am I going to move this? Move this over here. Yeah, move it here. Because we won't need both at once. Then I can get to my notes over here. Moving forward. Okay, so day three, we covered recon. Right, like we covered recon and web architecture, kind of the two components of this here. And Uh, our big picture goals, right, are to make sure that we understand that vulnerabilities aren't random. They come from architectural assumptions, and they come from things that we do, right, and things that attackers do. They come from things devs do, and a combination of that and things attackers do. Right, so we're kind of trying to weave everything together here. This is our last really lecture heavy talk for a while. It's class 5. There is no class 4. I had a guest lecturer. I'll cover some of the concepts of what he did at the beginning of class 5 for the online slides I'm creating in these recordings. But there is no class 4. But class 5 starts out where we're probably going to lecture for 20-25 minutes. And then we're going to move into more hands-on stuff because we're moving into session hijacking. So let's go through the things that we have to get through today. Let's see. I need to make sure that I am on the right source, and I want this. Okay, cool. So I asked at the end of day one, what assumption do you think developers make that attackers do not? Right, and those answers are largely around. They assume that everything's going to take the happy path, right? They generally assume that their code is going to work. They don't consider security requirements when they do that, and they don't consider edge cases in many cases. So attackers, they're not looking for the happy path, right? They're looking for ways to do things, and they're looking for flaws that are exploited in ways that developers don't even consider the software may be used. So on day two, we ended up with a mapping exercise talking about, in particular, Blackboard, which is a University of Toledo software package here. And I'd like to take a couple minutes here, I think, and just go through what that mapping exercise looked like. Right. So we're going to go through it without scanners, without proxies, and just observe. Right. So the URL, and please don't hit it, right? Like, or please don't attack it. It ends up being, I think it's blackboard.utdl.edu. So the University of Toledo's distance learning platform. Right. And what are we trying to actually do here when we do this? We're trying to map the structure of the website. We're trying to figure out where the trust boundaries might live, where state might live, and we want to look at the various objects, right? So let's go ahead and do that, right? So there are three things that we're going to do here, and I'm going to switch to this window, right? I think that this is probably a good spot for us to live, right? So let's figure out how we add some text boxes here. I'm pretty sure that we can do that. Like here, maybe. No, those aren't text boxes. How do we add a text box in draw.io? Oh, look at that, a text box. Cool. So we have pages, right? Features, right? And flows. Okay, so what are we looking at here, right? So we can very quickly just go to, and I guess I probably ought to make all of these a little bit bigger. So we're just going to do this. That's probably just as easy to do this and do it that way. So it's a little more readable. There you go. Okay, let's open a new window here. Actually hit the URL, right? Okay, so I immediately get prompted. This isn't my password there. Oh, that's fun. Oh. Yes, I still use LastPass for my personal stuff. Cool. Okay, so it didn't actually challenge me for MFA. That's fun. So we log in, we can see my class here, right? Again, I'm going to try to not go into this and accidentally dox any students that are in it, right? But I teach this class here, right? Like, but we don't even have to. We'll just go into here. So I'm just going to go here. And I believe if I don't do that, I've got some stuff to grade here. But if I go into here, I think this is enough for us to start thinking about that. Okay, so the first thing to note here, pages. What is a simple page we have, right? Like, well, we have a login page, right? Like, for sure we have a login page. We can just make a bullet list here for this. There you go. I don't know why it's doing that, but let's left justify it. Okay, well, sure. Yeah, draw.io is probably not my favorite thing. Let's make a line here. Hey, a line. Cool. Yay, we did it. Okay, good enough. Okay, so we have a login page. When we hit that login page, then we hit a courses page, right? So those are definitely things that seem to exist. Let's move this down. What else do we have? Well, if we want to do a course page, we have a course, right? A page just for that course. We have a gradebook page, messages, right? What else do we have over here? Resources, announcements, calendar, right? Cool, that's probably good there, right? And then if we look at those things, right? Like what features do we have on the site, right? So we can go, well, we have the ability to log in, right? We have the ability to send files, right? We can. This is a whole lot of no fun. I didn't think I'd spend the whole time arguing with with the tool here. Okay, what else can we do? We can send messages. We can enter grades. It's an instructor. Right, we can submit assignments. Right, and there are a bunch more, right? Like in the end, I don't care about all of them here, right? Like we're not trying to make a comprehensive list. And the same thing with flows. We'll just go really simple there, right? Like we've got, let's say we've got a login flow, right? Like what happens when you log in? Well, you know, in this case, it looks like it's federated login. So you hit a login page, the same as the university's main page, or it's not Blackboard, it's federated to the university. So we hit that, and then we go back. It's probably SAML or OAuth, one or the other. We have a view class flow, I'll call it. Right, when you log in, you kind of go through the app, right? Submit an assignment flow, right? And those are multiple pages. I'm not going to go any further than this, right? I'm just trying to kind of give us an idea here of the type of things we're looking at, right? So as we document these things and these pages that exist, right? We should also document maybe their URLs. We should document some things that are common to them. We should document any observed behavior or any assumptions, right? Like it is observed behavior that the login flow for this page seems to be federated to some sort of federated services, probably ADFS in this case, right? And that's super relevant, right? So we're not using tools here. What we're doing is we're trying to make ourselves a rough roadmap of what this actually looks like, right? And this is a very relevant information that we end up using later when we actually try to formulate a plan as to how we're going to attack these sites. So that was the day 2 mapping exercise. We went through it in class, probably spent a little bit longer on it. And the student's assignment is to do this exercise for another site of their choice. So chapter 3, how are we architecting web applications, right? Like what does this actually look like? Well, a lot of this is going to be repeating the same thing that I've said over and over again, right? We're trying to really drive it home. And, you know, the first thing to note here is that security isn't a feature, right? There isn't like, hey, I just need to enable the security feature and everything's good, right? Security is a property of proper architecture and proper design decisions, right? It emerges from the thought that the app is well architected, it's got good structure, data flow is considered, and we considered where data is going to get hand off and where it's trusted. And where possible, it emerges from not assuming things, right? It emerges from facts and not assumptions. And where we get bitten all the time is developers make assumptions. They assume that, well, if you have a token, you must be valid. They assume if you have a session, you must have gotten it the correct way, right? So, uh, it what we're trying to drive here is that, uh, you know, these vulnerabilities, they're architectural consequences, right? And that was covered in the reading that we did in the book. So how do we see systems differently, right? So again, right, like this is more in the day one consequence here, or the thing we talked about from day one, right? The developers, they tend to focus on the usability and where we're trying to drive an application, right? They consider the intended use. They consider the happy paths, the trusted components in the correct state, right? And while over time some software development practices have encouraged them to consider the other paths, right? Like it is almost always an afterthought in my experience, right? Whereas us attackers or those people poking at these applications, we're considering how does it actually behave, right? Like what are some unintended consequences? What extra information are we giving, right? Like what happens if I hit things out of order, right? Like we mapped flows through the Blackboard. What happens if I do some of those flows out of order? Right? What happens if I hit the grade submission before I've entered picked an assignment, right? Like where are those edge cases that I can try to get through, right? Those edge cases are on paths that aren't the happy path. And then what can I observe, right? Like I've talked about the F12 hacker a number of times, right? The developers designed for the fact that the front end was the only way that that data would be viewed. So it didn't matter if they sent back extra data, right? Like, whereas an attacker considers all data valuable and they see what they can observe of it. It's really common for APIs to leak additional information. And then attackers look for places where we can mess with state, right? Like as we talk about session hijacking in number 5 or day 5 here, as I post it, we'll start talking a little bit more about what that state looks like. And the reality of it is here is these are just different views of the same systems, right? Of the same application, and developers consider it with a different set of assumptions than most attackers do, right? And that's very relevant. So, what does the canonical web app look like? The traditional web app? Well, it has a client component, almost always a browser. The browser may be on mobile, right? And in some cases, it may be an Electron app these days, right? Like there's a number of other things you can do there, right? In most cases, we have a server on the back end. Now, that's not universally true. There are client side only apps that use nothing but JavaScript to do things like simple calculations. But in reality, those web pages are usually served from somewhere, right? Even if it's a local file system, right? So we'll consider here that we have a server that has some sort of application logic, although it may not actually be any logic. If the application is anything but the simplest application, we probably have some sort of persistence mechanism, right? Be it a traditional relational database, a NoSQL database, a document database like Mongo. I don't know why anyone would use that, but it's very common. As well as maybe a key value store, something like Redis for caching, right? Like we have a persistence layer because HTTP is stateless, so we need to keep track of at the very least where we're going. But usually web apps are a lot more useful if you can actually save things, right? So we have some sort of area where we save them. And then we have some subset of external systems in a microservices application. We could have a ton of external services called from the front end web, right? Like the server may call dozens, or the client may call dozens of backend APIs. The server may call third-party APIs, right? Like you saw in the case of Blackboard there, right? There's an integration with Active Directory Federated Services at the university, right? That's an external service. It also has additional integrations you can do with various tools, like I think it supports embedding videos from YouTube, right? And these are all external services that we can hit. But what does this diagram hide, right? Like, what are we missing here, right? And the big thing here, and it's covered in the book, is that the diagram, like if we diagram out the canonical web app, that web app, it just describes the intent, right? Like it doesn't necessarily describe the reality of how it's architected. And especially as we move towards single page applications, more and more of this business logic is moving to the client, right? And it's kind of upending where this stuff lives. So that drives us to the fact that the client's a suggestion, right? Hoffman calls clients adversarial by default in the book, right? And the reality of it is that many developers assume that the client, the web browser, the client that they're using to access the server is the only one that can be done. But that's simply not true, right? Any client side validation you do, I can use a proxy or any number of other methods to just do away with that client side validation for controls, for password length, whatever the case may be. Even if you do it in JavaScript, that JavaScript is loaded into my browser, and I can just open I can open the editor, and I can just modify the JavaScript or the state of the application inside of my browser. Right, so we come into this this thing here where the UI workflows, we just simply can't enforce them, right? Like there is no ability to ensure that a client side application, that the client side of it is running all of the data and all of the checks that we believe can be run. There's no guarantee that it's submitting the data that even was present in the browser. As we go through the next class, or not 2 classes from now, lesson 6, we'll start looking at Burp Suite, and we'll modify in-flight requests, right? So there is no guarantee that even that happens. So the big thing here is that if we only do security on the client, I 100% can bypass it. A little note at the bottom, and we have a couple of slides to talk about this later. There's CWE 602, right, which is common weakness enumeration 602. It's client side enforcement and server side security, right? That is, we'll talk about what those are in a little bit here. I have a little sidebar that we go to talk about these things. So again, driving the point home that we've talked about numerous times now, right? Because these are fundamental, foundational things. So I want to make sure that they're covered. Anywhere where we move data between systems is a trust boundary, and it's where risk appears, right? So if the browser is sending data to the server, it can be intercepted and changed on the fly, right? There's a trust boundary there. When the server's talking to the database, we have trust boundaries there. Where the backend application is talking to third parties, same thing, right? Like in the end, every single place where data moves between systems is an area that we can potentially attack, and we should look at it. I have a slide towards the end of this where we talk through that a little more, so I won't cover it anymore here. And every secure app depends on every one of these things being true, right? Like it now, you can have you can protect and defend against a lot of these flaws, right? But they need to be actively thought about, right? That users follow intended flows. Well, what if we don't, right? In many cases, people assume that if you can authenticate, you have access, right? Like that's not true. They're just because I prove that I'm a person, and we'll talk about this next week a little bit, or when I record session 5, because this is largely what we talked about in the identity lecture that Matt Lee gave, right? We assume that identities are not brute forceable, right? We generally assume that requests arrive in order and that state behaves predictably. We, as attacker, challenge every one of these assumptions, and they're depending on the class of attack, right? Like requests arriving out of order. That's probably less relevant for a web app, honestly. But there are plenty of places where out of order behavior can cause all sorts of state issues that makes the state behave unpredictably, right? So I think that's the lesson here, is that you don't need to hit all of these things to create issues. All you need to do is leverage one of them that may make another one fall over, right? Like, request arriving out of order may make state behave unpredictably, right? It may do bad things to the backend state. So as attackers, we just need to challenge every one of these assumptions. So if we don't want to talk about things with the traditional web, the web diagram, what do we want to do, or how do we as attackers and even developers, how do we want to consider this? And I would challenge that the reality of it is that we should be doing data flows. When a user supplies input, what happens to it? What external systems are called? Where is that data persisted? How is that response generated? Right? Like all too often, I see diagram maps. Let's see if I can find an example of one and drag it over here. Let's see. I'm hunting one. Sure, we can just use this. I mean, this is one from Oracle. Hopefully, they don't have issue with me using this page, but like this is basically a universal service map, right? Like of how a universal service mapper works, right? We got a consumer that talks to an event listener, right? That has an orchestrator that maybe invokes some external services and then persists data in the database, right? But like I would argue that that is actually a relatively bad way of diagramming that, right? It doesn't expose what happens to many of those things. I would argue that in many cases we would be better off using, and I'm looking for an example of one here. Yeah, okay. We'll go here. Something like this, right? This is a data flow diagram. So the customer has an order, it goes into the order food service, right? Which then the order goes to the kitchen, right? Like it comes back out as a bill. The order goes to an order entry, right? Which then makes there's reports that can get done here, right? So what we're describing here and what we're showing is how data moves through the application. It shows all the systems it touches. It shows all the times it's persisted here in these orders, right? It shows the actors here that may be dealing with them. And if we approached it from a data centric model, we're often much better off trying to determine where those boundaries might break, right? Like, okay, so we call order food, the order goes to the kitchen. Well, what happens if in flight the order is modified and we only have 10 widgets, 10 heads of lettuce in inventory, but they've modified the request to require 13 of them? What happens? Do we now have -3? Is there some sort of exception? And that's a mundane example based on a really simple data model here, right? But like, I find visually mapping how the data moves from one area to the other gives us a much better understanding of what these things look like in the end, and we end up in a much better place. Right, and this is key there at the bottom, right? Many, it says most, but many vulnerabilities map to where data is trusted too early, and that is generally the case, right? Like thinking through all of the SQL injections, I mean, yeah, we trusted the fact that that data that got injected was safe, right? And it was not. And so many classes of application can just come down to data being trusted too early. We're going to take a little sidebar here and go into, and this is as good a space as any to cover this. Why do we group vulnerabilities? I made reference to the CWE earlier. We've made reference in this class to the OWASP Top 10. So I think this is a good place as any to talk about why we do that. There are thousands of vulnerabilities, right? And as we talk about them, we have commonalities in how we in what they mean, right? We have commonalities in how they're represented. So we need a common language to discuss. And in this class, we're going to use three things here. I know I cover two of them here. Yeah, I only cover two of them here, but the third is the CVE, right? Which is the CVE is an example of a of some sort of vulnerability that exists, and we'll talk about that in a second. So the first thing I want to talk about here is the OWASP top 10. I'm gonna just open the browser here, right? And so here is our OWASP top 10 in 2025, the latest version of it, right? We have A01, broken access control, security misconfiguration, software supply chain failures, cryptographic failures, injection, insecure design, auth failures, secure software data integrity failures, security logging and alerting failures, or mishandling of exceptional conditions. These represent classes of vulnerabilities that may contain multiple CWEs, and you can see here on this page it actually lists many of them that are included in this, right? So what the OWASP top 10 does is it allows us to break down the most common vulnerabilities that we see in applications, right? And as a developer and as an attacker, a red teamer, or as a blue teamer, knowing that the weight of this and the incident rate is 20% and it covers 40 CWEs, right? Like we probably ought to make sure we don't have broken access control, right? Like we probably ought to make sure we aren't misconfiguring things, right? Like in the end, right? Like we have tons of occurrences and applications here. So what the OWASP top 10 does is it gives us the ability to basically say, hey, like these, if you're only going to do some things and you don't have an unlimited resources to do all of them, what do we want to do? And the OWASP top 10 is a good starting place, and it's a place that we'll anchor a lot of the coursework on. So it's a curated list, right? It's updated every couple of years. 2025 is updated, and it's two things. It's not exhaustive. There are plenty of vulnerabilities and weaknesses that exist that aren't in the OWASP top 10, and it's not a checklist, right? Like again, I said if you only have resources to look at one, it's a good place to start, but it's not. There's no guarantee that if you do all of them and you pass all of the OWASP top 10, that you won't have a vulnerability. But if we're going to look at where we look at our effort and where we're going to put our training, it is a good place for both red and blue team. It is a good place for us to start. That moves us into CWEs, right? It's common weakness enumeration. It's a MITRE thing. And there are hundreds and hundreds of them. And they describe why, from a technical level, a vulnerability may occur, right? Like it's a lower level saying that, you know, a good example here, CWE, improper input validation. Let's see. I had the page open here and I'll go back to it. Okay, so like here's CWE 352 cross-site request forgery, right? Like the consequences will vary on the nature of the CSRF, right? Like it. So you know we can go on this page and we can say, you know, we have some sort of component here that makes it up, and this page gives really great examples of it. It gives examples of CVEs that have come from it, right? So again, what we have here is we're building a taxonomy. We're building a common language that we as attackers or defenders or developers, as a matter of fact, can use to discuss what vulnerabilities actually are and where they're occurring, right? So as we go through the rest of this class and we start looking at things, I'm going to try to map a lot of the things we do to CWEs. And if they are present in the OWASP top 10, we're going to talk about them. So how does this all connect? Well, we have architectural assumptions that may be broken that lead to vulnerabilities that map to CWEs, so common weak list enumerations, that may in turn map to the OWASP top 10, right? So what I'm saying here is something that we've said over and over again, that all of these categories and all of these things we talk about, they root from the same problem. They root from architectural assumptions, or, you know, bad error handling, or trusting data too early, right? They all map to the same things. So again, vulnerabilities aren't random, right? Like at the input stage, we can have injections, right? If I'm able to take arbitrary user data and process it, then I can inject there. If I can reflect data back to the user or modify what comes out the browser, then I have cross-site scripting, right? Like in the logic phase, right? Like maybe I have broken authentication or I'm doing something silly like relying on exceptions to handle whether or not auth succeeded, right? I might be able to bypass that, right? Auth bypass is something that's really common, and you'll see it in a lot of vulnerabilities. Like there was just a FortiGate one that came out where essentially it comes down to auth bypass. I can bypass authentication and get access to something I shouldn't, right? Another example there is IDOR, right, which is IDOR stands for Insecure Direct Object References. So basically, I'm accessing something somewhere, and if I can tell it to access it somewhere else, uh, then bad things happen, right? So like if I had a URL where an ID was in it and I just changed the ID and I got the other ID instead, that's essentially an IDOR, right? Like in the data stage, you know, we still have injection, right? Like if that data goes all the way back out, then we can do that. And then at the output stage, we have, you know, again, cross-site scripting. So you can see that these things repeat themselves, right? And we can protect them in multiple layers, and we should, as blue teamers, to protect them at multiple layers. And again, right, like the things we're discussing here map directly to A01, A03, and A07 in the OWASP list. So in the end, we can learn a lot about systems and sites that we're attacking, the architecture of them, without ever exploit, without using tools. We can figure out what objects look like, right? In the case of Blackboard, there's probably a student object, a course object, a message object, a grade book object, right? What do those things look like? We can start to figure out where state lives, right? Are we using JWTs for authentication where the state lives on the client, right? And we're just validating it on the server? Are we using a traditional session cookie? Are we using view state? That's one that's been pretty big right now because machine keys have been compromised, right? Are we using view state where, you know, we're just storing the entire state in the web page and it's encrypted with some sort of key, but those keys are common and reused so we can decrypt it and modify it, right? Like, can we, so without tools, we should be approaching the things that we're looking to attack and in logging and writing down somewhere the things that we discover about them that can be used later as we go into tooling. So I feel like I was a little long-winded in this one, a little repetitive. So let's go ahead and end. I stood a CTFD up. If you are reading this not in my class, you probably don't get to use it unless you happen to be Toledo, in which case you could get an account, but you probably won't be able to actually get into the CTFD. In class, we walked through Challenge 1 together. Actually, today, the rest of it is due. And then for the next session, I asked them to read the session hijacking URL. Feel free to go through and read it if you are following along. And yeah, they had some homework, and it's all due today. So that's it. Since you are remote, there are no final questions, and I thank you, and I will see you in the next one.